Can we get bigger?
Oh, is it also small?
Yeah.
No. Why don't you get started and I'll try to figure out that this is basically.
We still have 1 minute, so that's fine.
PDF was working fine, but I have no idea. There are no other buttons here. No. This is what we get for presentation.
Strange. Right button.
Now the lady that was asking if everything is fine is gone.
Yeah.
Well, the PDF, most is PDF, so they should be fine. So
Maybe you can use the PDF version of this.
not like that.
Not too bad.
It's still,
Okay.
that's over there.
Okay. But this doesn't work.
I think for the PDF it was working, but
Okay. Hi everyone. Welcome to the Anima session in IETF 102. This is a note wheel, so everybody should read that before you enter this room. And we are actually going to ask the HR question for every talk before it starts. It should do for every meeting we had, but we didn't. But we'll pick up from this meeting.
So the official process, that we learned is RFC 6702 basically says that we should ask whenever we accept something to be presented. And so because we've kind of not done this and we'll do that from next meeting on, we'll just ask when it's being presented.
We'll give out the blue sheets around and make sure you sign it before you leave the room. Anybody on the Jabber? Are you on Jabber? Okay, so yeah, we need a Jabber scrubber in the room. I don't see one. Yeah, maybe you can do that. And we need a minutes taker. Any volunteer?
In there?
Bing? Thank you.
I'll do the notes when you're presenting.
Yeah.
I'll do a bit of job.
Thank you, Brian. We have also the remote participation, and all these slides already uploaded on the website. So both people remote and on-site could check it. As usual, the main working place for IETF working group is main list. So keep invoke discussing on mailing lists. And this meeting is chaired by myself, Xing, and Teresa. This is the meeting agenda. We had a quite full agenda today. We will have 4 working group draft. Each of them has only 10 minutes or less, because some of them already reached the end stage of the working group document. So hopefully those would have sufficient time for them. And next we have the outcome preparation of NUC service in SAP networks. And we have the bootstrap key infrastructure over the IEEE environment and the Next has the autonomic function lifecycle management together with the coordination between autonomic function and knowledge exchange done by Laurent, and the Anima domain binary by Brian Carpenter. Then that's the information distribution in autonomic networking by Beam, and guidance for the autonomic service agent together with the transfer packing data over grasp by Brian. And at the last, it's the trust networking and procedure for autonomic networking by T. Any agenda bash? 1, 3, goes. Okay. This is a very brief summary for the milestones data. We have managed to publish 2 RFCs since last IETF meeting in London. That goes for virtual and stable connectivity. We actually, before that, we already had 2 documents, GRASP and prefix management, reach the RFC publishing procedure, but has been held down by the missing reference. Hopefully, we will be able to do that within this year to have all the missing reference ready. I just get the information CTDAO from Cooper already in the procedure for publishing, so SAP is in the way by itself. Yeah, we have the SAP draft submit for IEST publication. It's waiting for the IEST evaluation, hopefully in early August. And we have the reference module submit to IEST in May, and still waiting for the AD evaluation. I think that will be rigorous.
Slides, yeah.
All right, okay.
So the quick summary is maybe original goal, the first round, 7 documents, 2 are out now, right? So since last IETF. So the first 2 RFCs that we have, 2 are still held hostage in the RFC editor queue. So it's the 3 others that we're basically just pushing through to get all the remaining 5 released.
Right. So that gives us, we have actually 3 documents in the current working group stage. Bootstrap key infrastructure, it actually already passed the working group last call last month, and it's planned to submit to ISG this month. And we newly adopted Grasp API in December last year, and the constraint voucher adopted in April. And so far, do you want to give me some words for rechartering or at the end of the session?
Yeah, we can take it at the end.
Okay. Okay, that's the status summary. So we can start from how to go this.
Sorry, let me look.
Yeah. IETF give us some new terminal to, in order to get rid of all the chairs, but we are still learning how to use this new terminal.
Okay. Bing,
Okay,
come up, or are you? I don't know who's presenting. Are you presenting? Okay. Clicker.
Good morning. My name is Kim Liu. To give a very quick update. I don't be grabbing the mic. Yeah. Okay, I'm giving a very quick update of the Grasp API draft.
This is a reminder of what is the API about, because the Grasp stack is located in the kernel space, and in order to let the user space ISAs to share the same functions, we need an API between them. And there are some standard functions already defined in Grasp. For example, the discovery and flood and negotiation, synchronization, etc. And in the future, we might also have some additional functions. So we can also add these functions to be called by the ISAs, as the picture shows the extended function library. So here are some little change from last IETF. We had some discussion regarding to the event loop. The comments were made from Ignace. And the result is that we added a notify function to inform the event loop that something might be changed, is already changed for the session. And the event loop is for the constrained devices that are not capable of doing multi-thread grasp. And we're also considering to align the error code values to be consistent with the standard socket API, because as you can see in the figures, there's a IPC between the API and the kernel. So it is actually buried by the socket API. So if we can align the error code, they will be more consistent. Okay, that's the quick update. And we still need experienced C coders to help us to verify the current design and do some mapping to C code, because the current prototype is based on Python. And we also have another collaboration project is under developed. They will issue the Grasp based on C code maybe several months later. Okay, any comments?
Okay, thank you very much. That's me. Okay, wanted to give a quick update on the ACP draft. So we were at dash 13 in London. We went through about 50% of the IETF IESG review, 5 more votes on the IESG to go. There was a lot of work done between 13 and 16 now. Not really any technical changes about what the ACP spec does, but a real good amount of technical explanations coming back from the questions from the reviewers. It's on the IESG Telechat 1st of August or 2nd of August. So here's basically a summary of the high-level points that were added. So applicability and scope, for readers to easier catch up in the beginning of the document. More details about CRL, certificate revocation listing. We didn't have the security AD review yet, so hopefully we're already getting in better shape for that. Lifetime of certificates, re-enrollment of certificates, so all this certificate management, the things that we were expecting to be understood, but then most of the reviewers weren't assuming that was the case. So we had a lot of informational text in the document at the end, which I split up into 2 sections. One is what I consider to be really the important stuff, even though it can only be informational because it's all the operational aspects. So that's basically now the new section about registers I'm going to talk about. and then the existing unchanged one, diagnostics, and disabling the ACP. So those things are not related to protocols, but operators, unless we do a Yang model, this is informational here. And then the other stuff, I moved, the discussions about why we did things and what we could do in the future. That might even go into an appendix through the final IESG review. I don't particularly like the ordering of appendices, but that's the point. So the big new thing being done was adding a lot of information about registrars. And, the way that we originally tried to split up the work was that we were thinking, this was all in Brusky, and, when time evolved, we figured out that Brusky is, of course, the preferred, the mandatory ANI solution for the registrars, but that we're also trying to make, all the documents grasp ACP, Brusky, independent from each other, so that adopters can start, implementing and using each by themselves, which also means that you should be able to implement ACP with the whatever mechanism to manage your certificates. And that was basically what I was trying to describe with the ACP registrar, where that it can be anything. Brusky, of course, being the preferred method. So one other possible protocol, for example, that we could see being used in netcom-centric environments would be versions of netcom zero touch plus extensions instead of Brusky, of course, using the voucher and all that security mechanism, just different signaling steps, right? And ultimately, and this is hopefully we're going to have a little fun, Brusky is the best registrar system that we have thought of so far. So just to understand that we're not depending on Brusky, what is the worst one? And that's basically this slide here. So it's a little bit small, so hopefully it's visible, but registrar. This is the registrar. Yeah. You can be a registrar, apply for the job, right? Everybody can do it, no requirements. I've actually done it, right? So you've got your pledge, you basically need to get a bloody certificate into it. You've got a certificate authority, right? That's where you can get, certificate signed. So first you figure out the identity of the pledge. Then you basically ask somebody, hey, is this pledge allowed, right? Then you basically need to also give it an address, right? The certificate in the ACP has the ACP address, so you need to do some address management, right? So a whiteboard will do fine, right? And then, of course, also if the pledge is a secure pledge and doesn't let itself be configured without getting a voucher, well, you need to talk to your friendly master, right? And then finally, you can put the pledge, the certificate on the pledge, and the pledge can go and live happily ever after in the ACP. Right? So that's basically the process. I've done this manually for verification a long time ago, and so basically we can have any type of protocols, people, or whatever it is, and we'll just call this ACP registrars, and that's kind of what the text now says. These are kind of the interactions that a registrar needs to do.
Brian Carpenter. So I like the fact that you have an explicit domain admission controller there as well as the explicit MASA. I think it's sort of, I'm not quite sure whether that is discussed in the ACP draft because I haven't looked at that bit of the text, but I know that's a point that's left vague in the Brusky draft. Now, I don't actually care which of the two documents says clearly there is a separate function, which is the domain admission controller, but that has to be said very clearly somewhere. It's not part of a protocol spec, so it's something we don't have to describe in detail in the protocol spec, but we need to say it exists.
Right. So I think there have been differences. Point well taken. There have been differences in how different authors have been dealing with the non-normative part of the text. Right. There are authors like me that prefer to elaborate more than necessary, and the ones that maybe prefer less than necessary. We had this text in Brusky, and right now it's gone. And I'm trying to remember the reasons for that, because basically you could write everything or nothing. So maybe it's really, as you said, just the minimum statement. Some entity needs to perform the admission control, whatever mechanism it is, right? So that's maybe the simplest thing we're going to put back. Okay, yeah, and so basically we've got two sections. So the normative section is really very small and really just says you must basically put the address in there, and to get the certificate. And then the operational aspects, you know, I've elaborated more. The registrar interactions, like I showed them, certificate renewal, registrar centralized policies. Yeah, so please, you know, if you haven't reviewed that part of the text, would be happy to get that feedback too. And that is it. Thank you. Yeah, so let me see. I think I need to go back.
That's you as well?
Yeah, I think it's me again, right, for the Brewski. Do you want it?
Yeah. Go ahead. Go ahead.
Yeah.
Can I ask a question?
Sure. Oh, of course.
Thank you. My name is Alex Gallis from University College London. I do understand very well the progress made, and that's remarkable on this part. However, I have some difficulty to understand three little issues. The main function of this control plane is to allow communication between, let's call it autonomic network functions.
Right. Mm-hmm.
In that sense, because they are network functions, they have their own control plane.
So
on its own. The
it's
question
a name.
is how
Control plane is a name. You could equally just say
Can
it's
I ask
just
a question first?
Yes, sir.
Before you answer, if you want.
Yeah.
The relation between the real control, let's say hosted control plane on the network functions already, and this communication facility, it's not very well, not clear to me. And that's the first question. Where are these interactions? The second question is related to the other function of this of the current control plane, which is about allowing an external operator or a management system to practically configure it. Now, if that's the case, where are the relevant primitives or the APIs to allow this to happen? And if it's happening, is it a control plane or it's a management plane issue? And finally, richness of the autonomic network function is not so well exploited, in my view, in this thing. It's too generic. So could you comment on these three simple questions?
Right. So basically, if you check the reference model, which is where we're giving an overview and a summary, right? The ANI that we're doing right now is really the basis of just, you know, any communication fabric that we need for autonomic agents or for centralized management. It basically does nothing more than basically giving you autonomically configured IPv6 reachability between your autonomic agents, service discovery through GRASP, and security through the certificates. And the same is equally available to anything centralized in the NOC. That's all. Now, basically, we're trying to get into the second stage of our charter when we actually have these things through the IESG so that we can start thinking about higher level things, which is where all the GRASP APIs and the other stuff that we have on the agenda comes in.
Which basically agrees that this is not a control plane, the term. It's just a name.
Right. I mean, the question is always, what do people understand under a certain name, right? So it's a name, yes.
Ryan Carpenter again. Alex, I think also some of the answer to that question is supposed to be in the ASA guidelines draft, because, you know, it is an ASA that actually manages object devices, target devices, or target functions. So the actual action of managing, you know, radio frequency assignment in a radio system or something is not a function of the ACP. It's a function of the autonomic service agent for that particular part of network management. So in a sense, your question is probably addressed to the wrong draft. Unfortunately, it's my draft that I'm talking about.
Well, in cars, right, the common part, right, in new cars, they call that the platform, and then they basically put the hood and everything on it. So maybe it's really the autonomic control platform, right, just the lower layers, and the ASAs are basically the hood with the passenger seats. So we'll see. Okay, just a quick update. Unfortunately, Michael, if you're willing, I'd be happy for you to chime in and say anything about Brewski. So I just wanted to give quick status update, right? So we've basically went through Shepherd review. We got one new IPR disclosure that I posted to the list from Juniper. That actually is an old one. It was just the IETF process that it has to be associated with every individual draft it applies to. So this was disclosed kind of as an IPR, I think 2 or more years ago already against the Netcom Zero Touch draft. So equally applies to Brewski. So Shepard write-up, and I'm trying to give this to the AD this week. There are a couple of minor formal nits. Brian Carpenter found this one thing where text had been deleted and not put back. So I'll probably try to mention the nits in the Shepard write-up and would like to get this thing going quickly into the IETF and ISG review. Man, that's pretty much all about Brewski, unless somebody else has questions or Michael wants to say something.
Michael drops off.
Okay. Yeah, probably northern Canada with an RV is a little bit difficult for network reachability. So.
Okay, thanks, Peter. That's,
Oh, good.
yeah. Yeah. I think that's the constraint. Yep. Constraint voucher, Peter.
Okay, this is my first presentation of this draft in this working group. Thank you very much. It has been accepted as working group draft, so makes me quite happy. It's about the constraint voucher. I will try to explain a little bit how it is situated with respect to the key infra document and why we wanted to have this. And what it does, it is has made an extension to the voucher for the constraint voucher with respect to the voucher definition. And what it also does is that in the voucher it uses young, and the young has very long identifiers. And what we have added to that is that we use the SIDs, which are marked here what it means. And instead of having these long identifiers, we just got the numbers, which has been which are based on drafts which are published in the core working group. On the other one, what the draft does, it instead of using HTTP, it uses CoAP, it uses CBOR, it uses CMS, and it uses COSI, which is also a facility to do end-to-end payload protection when transport. Yep, I will go in more detail. We have done, since the individual version has done some progress, we have defined DC. Yes?
Oh, I didn't want to interrupt at the end.
Good. You may interrupt now. Okay, so what we have done is, and I'll tell a little bit about it, we have introduced the CMS and the COSI media types, we have introduced the SID definition, and we have prepared the young modules, which are an extension to the voucher young module, which has already been defined in the voucher draft. These are the draft relations. As I see that, this is my view. So actually, there's much more in the world than is described here. But just to make the differences clear, so what we have is the Brewski or key infra draft, which uses HTTP, TLS, EST, and CMS. And what it actually, in my point of view, does with respect to the draft we're presenting here, is that it has EST with the voucher request. So instead of doing all the certificate request, you also have the voucher request. It has a MASA added to it, and something which is very important also to us, there's a joint proxy to go from the pledge to the joint proxy to the register, etc. for the registration. No? There is another draft which is done in ACE, which is called EST Co-op S, and what we also are relying on, and which it actually does. So it uses Co-op DTLS instead of the HTTP DLS of Brewski, and it uses EST, of course, and what it does, it extends EST with the Co-op DTLS. So it is EST, which is HTTP TLS, and the draft says it's EST with Co-op DTLS. So we want to use that for the constraint devices. Then we have the voucher one, which is based on Young and JSON, and it uses CMS. And what it actually does, it extends Brewski, in my point of view again, with the voucher spec. And then finally, we come to this draft. It is presented in Anima. Thank you very much. What it does, it uses Young and Seaborn instead of Young and JSON. It's to reduce actually the payload. It uses the voucher, but it extends the voucher with 2 fields, which permits it to have, instead of only the certificate, also a public key added to it, for which we can use for the security of the how's it called? Well, okay, for the process. So we have the voucher, and we have the Brisky with COSA CBOR, so which we use the COSA CBOR format and the SIDS, and we use the CMS CBOR with the SIDS. Why do we use 2 of these, COSA and the CMS? The COSA will certainly be used for the 6-dish working group, where they have the very, very small devices. And we will use the CMS in the case furthermore for the SDOs, which are still dependent on CMS and don't want to do all the investment and change all the products to immediately go to the COSI ones. So these are the 2 things which is defined additionally. What we think in the future is still needed is that we want a constrained joint proxy, which is especially done in the context of the Brisky for SDOs. Any questions?
Yeah, Thomas Eckert. So I was born into a time when we had the simple, manually defined TLVs. So drafts tried to be very simple because there was a lot of pain to write this up. So now I'm exposed to ever more different encoding things, and gets more and more complex and more versions because everybody has, so yada, yada, yada. Are there any real relevant functional differences between all these different versions if I eliminate all these differences in encoding? Let's say I'm trying to ignore all the encoding differences. Are there any other differences, or is it just all about the different encodings?
There are no, okay, this is about abstraction, and yeah, that's difficult. In principle, it's all the same Brisky process. You have a pledge, you have a proxy, and you have the registrar and the CA, and you have the vouchers and the MASA. So it's all about that. Only what is different is that we want to reduce the payload. Instead of HTTP, we want to use CoAP, which is more done for constrained devices, which is also payload. We want to be compatible with the whole CoAP environment. So you see the COSA, which is coming up there. And I think that summarizes it. Yeah.
Right. I think Elliot wants to answer maybe too.
Yeah.
Hi, can you guys hear me all right?
Yeah. Go
Okay,
ahead.
great. Peter, hi, and greetings from back in Switzerland. The only thing last week you mentioned was that there's a public key that's also transmitted as part of the voucher. Can you just comment about that, or because that's what I was trying to follow, and that might be a difference between the base Brewski and this.
You wanted me to comment on that?
Yes, please.
Okay, then I'm afraid that Michael will be much better in answering that, but it is foreseen that it's not only that he wants to use it, I think in the 6-dish environment, that we use the certificates, but there's also the possibility to use the public keys and raw public keys for the exchange of for the protection.
Brian Carpenter, by the way, Michael Richardson dropped off Meteco, so I don't think he's with us. My question is about the last line, the extra document. Do I understand that the constrained join proxy would not itself be constrained? It would be a sort of normal device, or it would be a normal sort of piece of software. So I assume that the constrained join proxy would talk to the registrar in the same way as a normal proxy, so there is nothing new there.
No.
So the only question I have is, how does the pledge discover the constrained join proxy?
Okay, thanks for asking this question, and I must say we are still working on that.
Okay,
Yeah.
if the answer is grasp, I'm interested. If the answer is not grasp, I don't care. I'd just like to know if it's going to use grasp.
I'm afraid you will be a careless person. Yeah.
Yeah, that's fine. I wouldn't imagine that grasp was useful for that, but I would like to be told if you do
I
want
don't
to
think
use.
so. I mean, one of the concerns is to make this constraint proxy also stateless, and how we can handle that. And there are 2 or 3 techniques which have been proposed, and one must take a choice.
I mean, we could always talk about a mini version of grasp for that specific case, but it's, if you don't need it, we won't do it.
Always open to know good ideas.
Okay.
Almost. So here are the CMS and COSA media types. So this is the register that we want to propose to Jana. And then the SID definitions, I mean, it is just for your information. You see here in Young file, young identifiers, and you see that instead of having those very long young identifiers, you can reduce them to only one number, and they have to be registered as well. So it makes more registration. What do we have to do for this draft to make it a draft which can be used and for interop and all that? So we have to update the example payloads. Given that we are working also on implementation, I think once we have the implementation, we'll use the example payloads, will come in, and we have to prepare an interop. We are quite optimistic about the progress of this draft.
Thank you.
Okay.
Yeah.
Any questions?
Okay.
No?
No more questions. Take it to the list. Thank you.
Okay, thank you for the presentation.
Thank you, Peter. So we already went through all those current working group document. So for the rest will be the non-working group document, or even some without draft submit to this working group. That actually means we are reach the stage for rechartering, and the chairs agreed to not take any adoption decision in this meeting unless we have further talking with our AD. What's going maybe next. So
yeah, I think the best sequence is to try to figure out what we would like to propose to the working group as recharter, discuss it with the AD, then basically we'll send the proposed charter to the working group list, and then of course we'll bash it out and hopefully will get accepted soon. And then of course afterwards it should be a lot easier to make the adoption calls for things without having to bother, oh, would they be in scope with the future charter or not? So let's just get the charter stuff done first, and then I think we'll all know the list of the candidate items. And so if you have any other comments, fine. Okay. So, all right. So we've got an INI device. The pledge enrolls with Brewski, right? Hopefully not with Homer Simpson. Fine. Then it's got a certificate and it's got an ACP running. Now what? It sits there idle. Perfect connectivity. What's happening now? So I've been doing this stable connectivity for the traditional networks where you have a centralized NOC that's doing everything, which is the way on how we can deploy the ANI today. And so I'm proposing here the very simple solution to auto-configure the minimum services to get a device that is, after Bootstrap enrollment ACP coming up, continuously through its lifetimes discovers the most crucial services that the NOC can have, so that the NOC can continue to auto-configure it, right? There are really, I think, very few services that you need to auto-configure initially. Obviously, that list is perfectly well for, when we adopt this for the working group for discussion. In my opinion, the first one you want to have is you want to have some accurate time, right? Discover your NTP servers. So then basically, the NOC needs to know what the heck is the node is doing, and the most, classical way on how to do that diagnostics is syslog, right? There are newer alternatives, so I'll ask my colleagues who are working on that stuff, but basically, most simple, you discover syslog. And then, of course, you need some way to remotely interact with the system, and basically, there are two kind of, most common methods. One is the manual operator method, which is SSH. The other one is netconf. Obviously, there are a lot more, right? If people feel that more alternatives are needed, we can perfectly add that. Actually, in many cases, netconf is just run over SSH. You can also run it over TLS, so those might be parameter differences. But effectively, the idea is that these services are auto-started, so that from the NOC you can log into the device and manage them, from a controller, or from a CLI. And then the question is, okay, what do we actually need to announce for that to auto-configure this service? And that actually is just an authentication mechanism, right? Because you can have all type of different instances like, Homer, Turles, whoever, the operators or the names of the different, controller systems are, and they need to have different access privileges, if at all access privileges, and those come from an authentication server. So what we want the NOC to announce are the authentication servers. So then basically, as soon as the ACP device discovers authentication servers, it can basically start these remote access control mechanisms like SSH, netconf, and basically if somebody tries to log in through them, ask the authentication server, okay, here are the credentials, what can this instance do? Right, so hopefully this is a good starting point minimum. Any changes, extensions, obviously more than welcome. Okay, how does this work? So basically, I presented, I think last year or earlier this year, draft accurate Anima grasp DNSSD. And that is basically a generic definition of grasp objectives to basically put DNS service discovery information into that, right? And that basically means anything you can do with DNSSD, you can basically now run over grasp. And that really just means on the NOC, the servers, the radio servers, or even a proxy for them, your NTP server, whatever you have, would simply send out these grasp announcement using this format. And on the right-hand side, I hope this is readable. There is the way it's represented in GRASP, right? So basically, this is the standard GRASP flood message, and then you have something like a name of the instance. The service is now syslog here, and there are a bunch of other parameters like your priority and weight, which are known from DNSSD. There are actually two interesting new things we can do with GRASP that we can't do with MDNS or unicast DNSSD. Well, actually, the second one you could do. The first one that I haven't actually shown is that we can do distance-based discovery, because we're hop-by-hop flooding. You can discover and actually use the closest instance of a server. You're always logging to your closest syslog, which obviously also means that the likelihood that it becomes unreachable will be lower, right? That's an important thing. And this stuff that I added there, if I want to have redundancy, I'm obviously wanting to log to multiple servers. So I need to indicate, okay, you find 20 servers, please log to your top 2 or 3. So that's another parameter I added. And that's pretty much there is about it. Yeah, so just the same in more detail written. So summary, we want to make the ANI network automatically use NOC services. The NOC services announce themselves via DNSSD over GRASP. So that's the flooding mechanism and also the message encoding mechanism. And what are the core services that we should consider? I think it's NTP, authentication, and authentication for SSH and netconf. Yeah.
Peter van der Stok, I'm driven by curiosity. I saw the DNSSD that you want to use. Do you want to export then everything which is known within GRASP to the DNS later on, such that you can, no?
No, at this point in time, it's basically an island, right? So we've basically been thinking about keeping it very separate, unless somebody stands up and say, here, I think, we need to have the following information swapped back and forth. And then, of course, that would be perfectly possible. I mean, a gateway from, MDNS, unicast, DNSSD back and forth to GRASP is perfectly possible. I just need to figure out the use case why we want it.
Okay, and the hybrid proxy, such that you have a central repository where all the discovery information is situated? Did you think
the goal is that, yeah, exactly, that we have the same richness of information, except obviously we can do a little bit more, like, distance-based discovery. But again, it's just a matter of use case, what type of proxies we want to define.
Hello, Laurent Chavalé, Nokia. Just want to understand a bit better. I mean, you propose to have a set of base NOC services to be automatically discovered and we'll say connected with the ANI and the underlying infrastructure. Is it on purpose that you limit to this kind of NOC terminology, or you can think about other services? I mean, I'm just thinking about, for instance, you want to subscribe or to discover some measurement or telemetry services that can also be of interest to the NOC. Is something we can extend to this approach, or is it you have a specific, really I would say application like NOC, specific NOC services, or you can branch.
Right, so the which I didn't represent, the DNS SD draft, right? So that really already says that anything that is described in IANA as a service, right, in the service registry, basically the draft describes that that is one by one the same that you can do in graph. So if you have any service you want to use that, the question is what new do we need to standardize? Right, so what I was trying to standardize here is the minimum that I would love every node that supports the ACP to actually implement, right? So current node, right? So again, it's a separate, it's meant to be a separate RFC. So if, you know, in the future people come out with much better nodes that don't need, you know, NTP, syslog, and so it's just basically meaning to have afterwards a very simple example, and B, also a very good subset where, you know, in an RFP, you can say, okay, do you support ACP, Brewski, and oh, I want to manage it from the NOC, this one simple RFC, right? So notwithstanding that, I would obviously love to apply this to a lot more service and other stuff. And if we feel it should be mandatory, it should go into this document. Otherwise, you know, if we feel it's more like a specific choice, I think we should put it into another document.
Okay, thank you.
Any more questions? Okay. Next, Owen.
Sorry, who should come up?
Owen.
Owen, you're up. Clicker. Wait, one more click. There we go. Is it? Yeah. Huh. What happens with you?
Okay, morning. My name is Owen Friel. Want to talk through a problem we've been noodling on for the next 6 months, or for the last 6 months, which is how to enroll a pledge over a Wi-Fi 802.11 network and use Brewski in the backend then for Bootstrap. So there is one related draft as well, which we're going to be covering on Friday in the EMU session, which is how you do Brewski at layer 2 inside of a TEEP tunnel. So that is a potential solution for some of the problems with Wi-Fi onboarding. So if you're interested in that, please attend the EMU session for more details on that. So what problem are we trying to solve? You power up a pledge for the first time. It could be your ultra-constrained light bulb, it could be an EKG, it could be an IP phone. The device powers up, it detects multiple SSIDs. Which SSID does it use to connect to? How can you ensure that the device is connected to the correct SSID and not, you know, the company on the floor above you or the company on the floor below you in the building you're in? What credentials does the device use to connect to the SSID initially? Because when the device first time powers up, it has its IDEV ID. And after the device is connected to the network, has done its initial authentication, it's done the Brewski flow, is enrolled. When it has its LDEV ID, how is network authentication managed? How do you manage that network authentication transition from when a device doesn't have an IDEV ID, doesn't have an LDEV ID to when the device does have an LDEV ID, and how do you do that on a Wi-Fi network? So what the draft outlines is the draft outlines multiple different potential solutions to these problems, but it does not make any final recommendations on what the correct solution is. It's more a discussion document for now. So there's multiple potential building blocks for solving these problems today. For SSID discovery, there's multiple IEEE standards that could potentially be leveraged. There's also Wi-Fi aligned standards that could potentially be leveraged as well. Trust introduction by the manufacturer, we know we have 802.1AR, we have the Brewski flow, and there's existing 802.1x and 802.11 specs for onboarding and for authentication as well. And for proof of possession, the Wi-Fi Alliance has Easy Connect, which is also known as the device provisioning profile for proof of possession. Anima Brewski mentions sales channel integration for proof of possession, but defines it has been out of scope. And so there's multiple ways of solving all these different problems. And what we need to try and agree is what is the workflow we want to chase for solving these problems, and then where the standardization needs to take place to solve the problems. So Bootstrap steps. High-level Bootstrap steps is the device discovers candidate Wi-Fi networks to connect to. The device does an initial connection to the Wi-Fi network prior to completing Brewski. At this stage, the device only has an IDEV ID available to it. The device completes the Brewski flow and enrolls, and then the device may have to reconnect to the Wi-Fi network now it's been credentialed. And we want to do proof of ownership, and depending on which solution we chase, proof of ownership could happen at any of steps 1 to 3. And there's multiple different technical solutions falling across multiple different standards bodies for how we could do proof of ownership. So looking at just some of the options for SSID discovery, these are all documented in the draft, but these are just some of the top ones. And we could define a well-known Brewski SSID and make sure the network operators configure that SSID name, then devices will know to connect to that. We could define an 802 extension to advertise Brewski capability. We could leverage a Wi-Fi Alliance extension. So Wi-Fi Alliance already has DPP. It doesn't quite fit the bill, but we could define extensions to DPP. And the fallback option is there's an existing 802.11u internet access advertisement. So we could build logic into a device that it sees an open network. It just looks for a vendor default registrar. But we need to consider device state machine complexity if we want to do that. Some considerations for authentication. So pre-Brewski, a new device only at its IDIV, it needs to reach the registrar. There's multiple possible authentication mechanisms that we could use for the device to make that initial SSID connection. Unauthenticated, the network could be enforcing WPA2 or WPA3 where a shared password is needed. And we could connect to a Wi-Fi network enforcing 802.1x ETLS, and it uses its IDIV for ETLS. And once the device is credentialed, Brewski is complete, device is an IDIV, the obvious authentication mechanism to use is 802.1x ETLS using its LDEV ID as the credential. But some considerations here, an SSID typically cannot support multiple authentication mechanisms, it only supports one, which means if you want to transition from pre-Brewski to post-Brewski using different authentication mechanisms, the device needs to connect to multiple SSIDs, the device state machine gets very complicated. Typically as well, if the device has to re-credential and connect to multiple different SSIDs, the device has to reboot as well, which again makes the device state machine very complicated. So when we're thinking about how we onboard a low-end light bulb, all these questions become really important. Looking at the authentication options, so I've categorized it into pre and post Brewski authentication options, and these are just some of the options that are available in the draft. Number one is the device connects to an unauthenticated Wi-Fi network pre-Brewski. It completes the Brewski flow. Then it probably has to reboot, switch SSIDs and re-IP to connect to an 802.1x network and use its LDEV ID. Option two is a device connects to an SSID network that's enforcing WPA2 or WPA3. We need some mechanism to get that WPA2 or WPA3 password to the device. DPP is one possible way of doing that. But again, if the device is switching from one credential to a second credential and switching between SSIDs, the device is going to have to reboot and re-IP and reconnect, which leads to a very complicated device state machine. Number three is the device uses ETLS with its IDIV ID. So it's doing 802.1x ETLS. It uses its IDIV ID initially. When it's credentialed as an LDEV ID, it re-authenticates using its LDEV ID. But again, it's 802.1x, both pre and post Brewski. One of the suggestions that we came up with, I think, at the bar in London at the last IETF meeting was we could define a potentially new 802.11 native authentication algorithm. And we could do the Brewski flow in 802.11 prior to network association. And finally, the one that we'll be discussing in a little bit more detail on Friday at EMU is do Brewski inside of TEEP by defining new Brewski TLVs to transport, by defining new TEEP TLVs to transport the Brewski messages. So when the device connects to an 802.1x network, the device completes the layer 2 EAP flow, and as part of that layer 2 EAP flow, it gets credentialed and gets its LDEV ID. So by the time authentication is complete, it is credentialed with its LDEV ID. We'll be talking about that a little bit more on Friday. So for proof of ownership, proof of ownership really means ensuring that your device, when you plug in your light bulb, your device doesn't connect to the Wi-Fi network on the floor above you or on the floor below you. There's multiple different mechanisms. Some of them are outlined in the draft as well. One is you could leverage what's alluded to in the Brewski draft, leverage the MASA and sales channel integration. So that means the MASA has an explicit map of what network operator owns what device, and the MASA will only voucher the correct network operator. So you connect to the wrong SSID, you won't get vouchered. Option 2 doesn't really prevent connection to the wrong network. Option 2 is the network operator relies on MASA logs to detect where their missing device is gone. You plug in a light bulb, you see it's powered up, you don't see it in your network. You query MASA to find out who owned it, who vouchered it. Number 3, you rely on network operators to be good citizens. If you connect to the wrong SSID, you're relying on the network, the wrong network, to reject your request. Now, we can't rely on that because a lot of operators will just configure permissive network policies to let any device on. And finally, option 4 is the network must prove some possession of a shared key. So there's a shared key associated with the device. It could be a public key, it could be a private key, and the device will not connect to a network unless the network proves ownership of that shared key. There's multiple ways you could do this, multiple technical implementations you could do this. You could use a handshake similar to Wi-Fi Alliance DPP. You could use a symmetric key and do something using TLS 1.3 PSK inside the read tunnel. There's multiple ways of doing it. So summary is there's multiple options available for SSID selection. There's multiple options available for SSID authentication. There's multiple options available for proof of ownership. Those options span multiple different standards bodies. So depending on which workflow we want to chase, the technical solution will live within the remit of a different standards organization. And we've been discussing this a little bit over the mailer on and off for the last couple of months, but I don't think there's any consensus yet on what's the optimal solution to build. And whatever solution we build, it should ideally work across all classes of devices, light bulbs, EKGs, IP phones, low-end devices, constrained devices, etc. And that is it.
Brian Carpenter, I think I'm developing a standard question because I have it about the base Bruschi document and the ACP. You know, there's a lot of focus here too on proof of ownership in the sense of proving that you're joining a network you're happy to join. But I want to hear more about the opposite question of whether the network is happy for you to join it. I think it's a slight, you know, it should be in your proof of ownership list of things to solve, how to make sure that the pledge or whatever you want to call it is actually authorized to join that network, which is the inverse question of whether the pledge wants to join that network. And the same thing is very likely dusted over in the Bruschi document and the ACP. So, you know, I think we need to be a little bit more clear that this is also one of the questions to be asked during enrollment.
Can I answer that? Maybe.
Yes.
Yeah.
Go ahead.
So right now what we have in Bruschi is that pretty much you can only join the network that owns the access that you're using, right? Whether it's a wired point or a Wi-Fi access point, right? So somebody owns this network and that's the domain you can own. He can reject you, but you can't own another network. You can't join another network, right? So, but of course we're also saying, hey, but I may be wanting to join over the internet, which is not owned by anybody, and I want to basically be, you know, joined into the right network. And that's what we've basically tentatively called Cloud Registrar. And there is kind of a more tentative and, you know, yada yada section in Bruschi, because I think it would require a lot more spec and standard work in a separate document to formalize that, right? And I think that really, to me, in all these discussions here is the first step that we should take. It doesn't matter if it's for Wi-Fi or something else, but you want to be able to have a method where you attach to a network where you can then get enrolled into actually your real owner and not whoever owns this access, like some strange service provider, right? And once we have that, I think then all these Wi-Fi things will become a lot easier, because then you can basically say, here is an SSID that allows you to join to whoever domain owns you, right? And once you've done that, you can also, of course, learn the SSID of the actual network that owns you. Might actually be that, you know, the first, you know, third-party cloud registrar join SSID that we have, however we want to call it, right, is the same, but, you know, you don't know yet.
Well, that's really what, it's the option that's described as sales channel integration, and it means that the MASA has strong identity knowledge and knows exactly which network operator owns which device, and that will be very challenging to build in a lot of scenarios, I think.
Well, so
Because if the massa doesn't explicitly know which network operator owns which device, you connect to the wrong SSID, you send a voucher request through the wrong registrar, and the massa just signs it and sends it
I mean,
back.
I thought in one email I was giving a simple example, right? I buy a device from some reseller. The only thing necessarily is the reseller basically, is sending to the massa or, whatever the service, doesn't have to be the same thing, the stuff, okay, this serial number was sold to this customer. That's the only thing required, right? That you basically get resellers into it. So I definitely wouldn't, say that we should exclude, documenting and defining this just because not everybody can do this, right?
Sure, yeah, but that is exactly the sales channel integration solution, which will be good for certain deployments, will be good for certain devices and certain sales channels, but won't work consistently everywhere.
Won't work for everything, but I think there. If I look at all the different tracking systems that I've seen, whether it's kind of from a large inventory list of light bulbs over to something basically reseller knows for bigger routers or so, all those cases I think it would work easily. So
Yeah. Alex, you're
Hi there. This is Elliot.
yeah.
So first, thanks for presenting, Owen. To Brian's question, right? Is the device interested in joining? So a device shows up, is plugged in, right? And we have some choices. And so one of the choices that's not on the slides that Owen presents, right, is, and it's not because it's at a low level, right, is the device waits to be invited to join, or the device actively probes to join. And then we get into, okay, what happens next? And so to Brian's point, one of the things that sticks in my mind in answering your question, Brian, or at least addressing it, I don't know about answering it, is what is the relationship between the device and the manufacturer? And what knowledge does the manufacturer have? So we presume the device was manufactured by the manufacturer. And so the next question is, what knowledge does the device have out of the box? Does it know anything about the deployment? The whole point of Brewski is that it doesn't, right? So this is sort of follow-on work. So it doesn't really know who to join. And so it needs some additional bit of information, either from the deployment or from the manufacturer indicating an authorization. Either can do. This is a discussion draft, so the point is to, well, discuss. Thank you.
all right. Any more questions? Thank you very much.
Thank you. Nora? Nora?
So somehow I ran out of time uploading what you just sent 15 minutes ago. Can you live without that? And okay, cool. Function lifecycle, the broken one first.
Yes, please.
Oh, okay, we got the. Now basically, let me control plus. What was it? It's getting small. Smaller on me. The second one was it? Control shift plus. There we go. Very good. Is that?
Can you go to the...
Clicker? Is that? Oh no, you have to say next slide. Okay.
Yeah, because that's
Yeah,
PowerPoint.
sorry. Yeah.
No problem.
Crazy.
Okay, so I will present three drafts that are more to present to the group potential new items for kind of phase 2. Those concepts have been already presented in the past, so the idea is to represent it very quickly and then get your feedback about if this is useful and also ask for collaboration on those topics. Next slide, please. So this is a proposal about defining a lifecycle management for autonomic functions for their deployment, especially from an operator point of view. The idea is that we would like to converge towards common guidelines on how to deploy and operate autonomic functions. So we have seen that in phase 1, Anima has developed the base infrastructure, how to install base services, connect to the NOC, or make a secure bootstrapping, install the ACP. But now, if you want to be able to deploy and operate autonomic functions, ASAs, on top of this infrastructure, it will be good to have a kind of standard way to do that from an operator point of view. Essentially because there are different types of autonomic functions in the same autonomic network, because they can come from different vendors or developers or whatever channels. And also because the interaction between those autonomic functions may have very different schemes. Next slide, please. So the idea will be that developing this lifecycle will help operators to concentrate only on achieving the goal they want to get from deploying those functions in the network, and not to spend effort, money, and time in understanding from each vendor how the configuration should be or the deployment should be, and make a uniform aggregation about all these deployment options on their own. So really get the use of the functions and not how to deploy and operate them. Second thing is to concentrate on the core functionality and not how to interface with the different network infrastructure. This should be embedded into the deployment of the ASA. Next slide, please. Yeah, so the proposal is very simple. There is an expired draft on that, but we propose a life cycle, and this will be the core of this talk. And also to support this life cycle, a set of different objects that we would like to specify for the ASA in order to make this lifecycle usable and automated. Next slide, please. So the lifecycle has a number of steps. I will not go through all the steps, but highlight in special the red part. So we start from an ASA being a piece of software that is, I will say, installed on some device in the network. And then we want to see how we can go from, to deploy, instantiate the different instances of these autonomic functions, and how we can also be in the operational phase, so instantiated and operational, and the different state transition and the different object that needs to be attached. Next slide, please. This I will skip. Next slide, please. So there are basically 3 objects or elements that we propose to specify and to add to the Anima specification. First one is what we call the ASA class manifest. So class manifest, a bit like in the object-oriented development, you can have ASA or autonomic functions class, like you want to do traffic engineering or, I don't know, congestion control. You can have a family of those different autonomic functions. So you specify a manifest, a descriptor about what does this function is doing, what kind of element it can control, on which device it can run, which version of OS, etc. So it's a description of at the class level. But this is important to get as a descriptor, because this helps the operator to understand what this class of autonomic functions can do and where it can be deployed. Next slide, please. So this is just an example that we have, some more detailed specification and also running implementation of that. Next slide. So in the ASA lifecycle, this mandate, so you have the class manifest, and when you are installed, you need to instruct your autonomic functions what you want them to do. So you send them a mandate, and this will deploy the autonomic functions over the network. Next slide, please. Okay, so the instance mandate. So here we switch from class to instance, because we want to, from the I will say the generic piece of code of autonomic functions, to go into different instances, deploy different ASA over the network. So here you need to have an instance mandate to specify for this piece of code exactly on which device it needs to be deployed, which resources it needs to control, the configuration parameters, the operation parameters. So it's really a mandate that specifies all the instantiated aspects, parameters, configuration parameters of the different autonomic functions that will be deployed over the network. Next slide, please. So now you reach the states where you are instantiating the different autonomic functions over the network, and you can have the autonomic functions to when they are deployed, to, I would say, feedback to the NOC or to the operator or to the management system the actual configuration when they have been deployed. So this is the manifest. Next slide. So this is the instance manifest. So we have the mandate. Mandate express what the functions need to do, and the manifest is the other way around, which is expressed that the ASA, when it's deployed, give feedback, give a report to the management system about this is how I've been instantiated on these devices, this node, using this configuration. So this is just a kind of a feedback mechanism. Next slide. So then there are a number of steps when the actual autonomic functions are running on the network, because I mean, ultimately you just want them to you just say run and everything will be perfect. But there will be some stages where you want, as an operator or as other functions, to be able to control the behavior of those ASA. So this is when you want to control when they run. So we need additional types of message to actually turn them on and off or change their kind of operational regimes. Next slide, please. There are also the steps of exchanging information or even knowledge between different autonomic functions, because in terms of interactions, you can have interactions that are given autonomic functions need information from another system to be able to perform well, or some functions may cooperate together to achieve a common goal. Some functions will conflict. So using information exchange, there are a lot of those interactions that can be either enabled or controlled. Next slide, please. Okay, this I will skip. Next slide, please. Yeah, so and what we call additional users is what I will express in the following presentation. So this is to describe a bit a proposed life cycle, how to deploy and operate in a common way those autonomic functions, and who will use this life cycle. So essentially the management system, the operator, to deploy, operate, and get feedback on the operation of those functions. But also there can be, I will say, other autonomic network functions that can also make use of the steps of this life cycle, of the elements of this life cycle, to interact with the function. So essentially, the next presentation will be on the coordination, as I mentioned, different interactions between those functions, but also exchange of information, and there can be other functions for the ANI. Next slide, please. So in summary, what we propose is to discuss and specify a set of common guidelines how to deploy and operate autonomic functions. To achieve that, we want to specify a life cycle and the different elements, information types, information flow, and data structure that are necessary to support this life cycle. And the idea will be to help the operator to concentrate on achieving the goals of the autonomic functions and not about all the mechanics about deploying and operating those functionality. And for that, of course, it's a bit also aligned with the work of Brian on ASA guidelines about, I would say, the how to design, how to specify the ASA themselves. So we need to have both the lifecycle, but also the interfaces and the descriptors about the autonomic function or ASA to be better specified. Next slide. I think it's.
Very good. Thank you. This work, which is obviously proposed, reminds me about Universal project which we work together.
This is the source.
It could be a source. It is a source.
It is.
So there is already some blueprint of this manifest already in place.
Sure. Yeah.
However, since then, few things happen, and I would like to comment on it. Pure connectivity-based autonomic functions is not anymore the main goal. In other words, it's a time to look at network services as well, because these are the things which driving now the network. And to my knowledge, there is already worldwide an attempt to virtualize, or if you want, softwareize 10,000 of such things gradually in networks. It may happen early in China and later in other parts of the world, but it's happening. So to some extent, this has to be looked in that sense, in the sense that softwareizing network functions with this additional quality related to autonomic nature. That's one comment. The second comment, once you do this, it's a time also to think in terms of adding some guarantees for the quality of service or the KPIs or any other elements into the process. In other words, a generic network autonomic function is not good enough without additional guarantees. And when you come to it, if you want to do it properly, in my view, it does not make sense to put them in a whole network because they could interfere to each other. And sometimes the operator wants a low latency network functions, and the other part want something else. And the two could interfere. Therefore, this is where slicing comes to end. Therefore, this loop of life cycle, which you mentioned, should be sliced aware. Otherwise, it's not practical in my view. So that's a kind but strong requirement in order to create a slice for some parts with some characteristic and another slice, if you want, parallel for other, as a way to easier, and this has to be taken into account. These are called precision networks, as I call. In other words, to have guaranteed KPIs, if you want, for a particular network service. This has to be, in my view, added to this process rather than to go for it. Some work was done here in a draft about slicing, and may be useful to come. But finally, this process will be successful if, let's say, a large number of autonomic functions or autonomic network service functions, put in this way, could be put in this place. Not 3, not 5. Mm-hmm. The scalability of this process, like a DevOps, as the end of the day, specific to this area, has to be developed, to be checked, and so on. So this have to be added here in order to make it more useful in that terms. What was done in Universal, it was pioneering work, but it's a time to move forward. And that's the 3 comments which I made to help, hopefully will help. Okay. I'm not sure what you think about it, but this is something there.
Thank you, Alex. Because I still have two presentations to give. I think these are very, very valid comments. What we present is really also to get the view of the chairs, but also of the group. But this is kind of proposition of a future item for the working group. So for sure, the approach is not fixed. What you mentioned is important to take into account in the discussion. So I think it's important to that we can discuss and define the scope of what we would like the working group to work in this aspect, if anything is to be done.
Yeah, I forgot the question. I had 3 comments on. The question is, once this work is progressing and maturing, it might lead to a slightly different infrastructure which is already developed in Anima to be changed substantially, to simplify it and to look at scalability issues here. And the type of infrastructure should be modular, the type of the things which are now developed as open source material in OSM or equivalent. So the question is, what is the impact of successful work in this area, like a new DevOps simplified, into the way in which the infrastructure should be adjusted? And that's a big question. One or the other is not simple to put forward, but at least as a question,
I agree
it's
with
important.
I agree with your point, Alex. I think if we are more than the 2 of us, that it's important to discuss this or to progress on this item. These are the things we need to list as criteria. What is the scope of what we want to do? What will be an implication for Anima? And then start to work on, specifying a bit more the content, the format, etc.
Can we, Leo, go to the next presentation or so? Because I think we're getting short on time. Yeah.
You can go ahead.
Go ahead.
Okay. Bin Liu, in general, I believe this work is necessary because if we this work could be considered as a kind of a meta ASA. Before any specific ASAs are running correctly, we must have some mechanism to make sure how the ASAs could be initiated on a device and how they could be terminated, and to also to make sure they don't have serious collision between different ESAs. So in this sense, I think it's necessary. Otherwise, we'll have to fall back to manual operations of these ESAs, which I don't think is acceptable in terms of autonomic network perspective. Yeah.
Yes.
So I'd like to see it progressed, come up with more specific protocol extensions or some not behavior requirements into details. Thank you.
Okay, thank you.
Just working on this. I have process comments. I think as the methodology, it seems pretty reasonable to have that together into the ESA guidance. But beyond that, you definitely need to define something new, including both interface and the comments you would like to set along the wire. So that maybe leads some new work there with a new draft, I guess. Okay.
Yeah, there is surely a link with the ESA guidelines, but as you mentioned, there will be some standard track aspect that should be understood and then put in a separate draft.
I can make it smaller. Is that okay? This is, I think.
You can use this. Can you use it? Can you maybe you can switch to mine?
So this is the first time we
give
have
that
this
to me.
notebook and, yeah.
I mean, give this to me.
Yeah, I think so. Or somebody fixes these Chromebooks, I think.
No. Yeah, it's on. Okay.
So this is a second presentation and highlights one specific aspect that can be, I would say, using the previous lifecycle management on some operation. The idea here is to highlight a problem, a well-known problem in when you have multiple autonomic functions running in a network, and ways to try to address it from a standard point of view. So coordinating multiple autonomic functions. Next slide. So first, why we need to coordinate this diagram. I don't need to go into the detail, but it's an example of different autonomic functions in a mobile environment context, where you have a set of parameters, a set of metrics, different, I will say, functions that use these different parameters and metrics, and the interactions of all these different functions together. So it can become quite complex to understood the different interactions, dependencies among these functions, parameters, and metrics, especially from a human point of view. And this is just for one, I will say, deployment. And this is what we call a static deployment. This is not a instantiated and deployed environment. So imagine that you can scale it by 1,000 instances. So those interactions are quite complex. So we want to have non-human interventions to coordinate. Next slide, please. So different types of interactions. There may be others, but essentially conflict, and it needs to be well handled. Cooperation or dependency between the different functions. So one function will need the outcome of another to perform well. It's complex to be managed by humans because of scale, speed, and island dependencies. The proposal is to have to coordinate the collective behavior via a common function that will be able to all AF. I mean, a bit like we have a previous presentation from Turles about NOC services. This can be a coordination services that any function can subscribe and say, if I have a conflict, then I may use external services to arbitrate the conflict. So it's not on the job of the AF, but it's a separate service. Next slide, please. There is a kind of coordination lifecycle also with 3 times or 3 steps. The specification time, you can already identify a set through the function descriptors, what metrics, parameters, functions, or what the function is doing. So you can already develop what we call a static map. So it's a priori knowledge about what will be the interactions of what if you deploy such functions. Then there is the deployment time when you actually want to deploy the softwares on the different resources. So there you have a more detailed knowledge and view about the potential conflict map. So this is the deploy conflict map, but it's still not a running instances. And then you have at runtime. This is where you already have all the autonomic functions that are really running, operating on the network, changing the different parameters and impacting the metrics. And then you have the dynamically updates the interaction groups and the interaction map. So these different three times needs to be taken into account and can relate to the previous presentation about the life cycle, about when you deploy, operate, and run your autonomic functions. Next slide. This is probably out of scope of what Anima could eventually specify, but it's just to give highlight about that. There are workable solution, potential algorithm and mechanism that you can deploy and that exist to address different coordination or interactions aspect of autonomic functions. So you can be really random token-based approaches, separation in time, hierarchical optimization, more or less sophisticated approaches or algorithm you can imagine that can be more or less also adapted to the different type of conflicts that you will face. I mean, some conflicts are very simple and you can just, by separation in time, you can address them. Some are really more complex to address because of the number of functions, but also because of the hidden dependency. And so you need maybe more sophisticated approaches to fine-tune the interactions. Next slide, please. So what we want to discuss here in Anima is the implication about this coordination concept and the services that could be proposed. We think it's important from an operational point of view to propose this and to manage this coordination in order to ensure the stability and the convergence of the network operation. It's a problem that is not at the scale of one autonomic function, it's cross-autonomic function, so it should be a reusable component. We require also a set of common descriptors. The function should express in a common way the parameters, the metrics, in order that these coordination services can arbitrate and make its operation over common descriptor and have this life cycle also. So we need also some level of common representation of information and knowledge, as highlighted in the conflict map, and also maybe some aspect of when you decide about what type of coordination you want to do, to make it executable on the network. So also a kind of interface to actuate on the decision of the coordination mechanism. And I think that's all.
Yeah. Seeing without my chair here, I really like the motivation of this work. I think that's important, but so far I'm not convinced. Given the, how complicated this work could be, whether that's feasible to abstract a common command set or not. So I really would like to see you take the design of this work into another level, with more detailed design, then we can really get down the ground to say whether that's work or whether that's, come enough to cover most of the ASA or not. Right.
Okay, so we have done some proof of concept on this, and especially as Alex mentioned, there was a research project where we have made some specification and running code. Based on your comment, the thing is that you will not reach a universal solution. We can specify some, as I mentioned, some interfaces and kind of life cycle, how we would like to approach this problem, but there will always be, I will say, specific solutions to be deployed. But okay.
Alex, sorry, we're already 5 minutes over his time slot, and he has one more. Can you hold it off after his third presentation? Is that feasible?
Yeah.
Because thank you.
Okay, I tried to be very quick on this one also. So this is the third presentation, highlighting another aspect, also ask for the research working group if it's of interest. So this is about knowledge exchange between autonomic functions. Next slide. Next slide. So why is it important? So we have already mechanism in Anima to discover, for instance, services or objectives that autonomic functions needs, but it's not always sufficient to have a discovery mechanism. The creation of knowledge is also important in autonomic networks in order to understand the context of the operation and be able to take more informed decision. So this is why there is a need to go beyond simple discovery and simple, I would say, data manipulation or information exchange and go to a level of kind of knowledge exchange and I would say reasoning on this knowledge to take some higher level decisions. So cooperation also in autonomic network relies heavily on the or emerge from the information exchange. Okay. I made the message. What we have tried to highlight in this draft, which is also expired, but the concept is here, is to we don't want the group to position itself on the creation of knowledge and the definition of what knowledge is. It's not that we want to focus on the mechanism, I would say common interfaces, common mechanism that any autonomic functions can have in order to subscribe to knowledge or to publish some knowledge. You can think about the PubSub approach. It's a good picture. So what kind of interfaces autonomic functions can have in order to get access to this knowledge and use this knowledge for their behavior. So this is kind of peer-to-peer relationship, but we can also think about this knowledge exchange between the common services of the ANI, ACP, or other services that, for instance, the previous presentation, coordination also needs some level of information, some level of knowledge in order to arbitrate between the conflict. So unified interfaces, management of information flow and common mechanism, because at the network scale, if you have a lot of information exchange between devices, you want to be able to optimize some flows, because sometimes if you have at the beginning 10 functions that send information to a given entity, it's okay. If at the end you have 1 million, maybe you want to optimize such flows in order to not to I would say to overload the network. So there are also information flow optimization, subscription flow optimization, so different types of aspects you want to also perform at the network level about this knowledge exchange infrastructure. Next slide, please. So in the draft, it's a bit detailed description about a possible implementation with some specification of functionality. This is not what we would like the group to really go over, but it's to give an example that this is feasible. But we really want to highlight the knowledge exchange and management aspect of about this draft. It can link to a very different aspect, like monitoring, measurement, but also to feed some learning mechanism or analytics mechanism, and also the information management, information distribution, and its optimization. So what we have in the draft would be to serve as the basis for the discussion about is it useful, is it needed, and what needs to be specified by this group in terms of interfaces and behavior of the different I would say entities that takes parts into this knowledge exchange, not only the autonomic function, but also the common services. I think that's all.
Okay, thank you very much.
Any question?
First of all, I like all these three, although they started some years ago. There are some examples exactly on this. But the situation a bit changed since then. Therefore, that's the reason I'm asking for some additional elements to be looked at. As far as coordination, this area is now called orchestration. And there are 8 open source orchestrators developed in the world, many other research projects dealing, all of them are about cooperation and coordination of different tasks within the area of the application. So there is a lot of body of how this may happen and how to create the protocols, if you want, for orchestration. That's one comment. The second comment is it does not make sense to me anyway to have one coordination or one orchestration framework for everything, because it's not practical in terms of how you deploy it, in terms of how you use it. So it has to be for a partition called slice. So for slice-based coordination orchestration, it is now the suggested option, because this will add value of the qualities of the orchestrators. Bearing in mind that in an operator context, there will be many orchestrators deployed. That brings another issue, how different orchestrator will communicate, exchange, monitor information for whatever reasons, and so on, which potentially has to be one topic. In a multi-domain, if you want, orchestration is now the norm. If you start without attaching this element, by the time you finish it, it will be already some desynchronization, what the expectation of. So multi-domain orchestration and interworking is one of the topics here to be added as far as I'm concerned, as a suggestion. But the work has to complete. And once this is completed, once again, the question is the infrastructure of the Anima, does it need to change to take advantage of this? Because it's our higher level management concepts at the end of the day, including the exchange of knowledge in whatever form, including the cooperation or orchestration in whatever form, including any other thing. So that should be listed there as a way to look forward. It may be that some of the Anima need to change a bit to take advantage of this. It's a chicken and egg situation, but it's unavoidable.
We're running really over time. Can we take this offline? That would be great.
Yeah, just a comment.
Thank you.
Thank you.
Thank you. Thank you, Lauren.
Is Anima running out of time, or is the session?
The session, yes.
Okay, so I should say before we start that this draft is not labeled Anima, because it's talking about an issue that I think is much, much wider than just Anima. But if it isn't solved in the wider space, we have to solve it for Anima anyway. So this is not about splintering of the internet. This is not about DNS domains. This is just about domains. Next one, please. So one fact that's undeniable, I believe, is that many types of limited domain are appearing in the internet. Home networks, office networks, vehicle networks, building services networks, SCADA networks in general, sensor networks, any kind of edge network in the IoT, enterprise networks, campus networks, data centers, hosting centers. By the way, those in particular, but in fact, almost any of these networks can be distributed. Network slices, they're limited domains, and content delivery networks, and there are probably other examples. You know, this is just to make you realize that limited domains in the internet are very common. And one of the things that's also come clear to me is that limited domain technologies are appearing in the internet. Differentiated services appeared 20 years ago, for example, and are explicitly limited to a domain within a domain boundary. Network function virtualization, service function chaining, NVO3 overlays, segment routing, autonomic networking itself. The ACP is very specifically a limited domain. Home nets are limited domains, so there's an HNCP protocol which is specific to limited domains. There's various creative uses of IPv6 are being mentioned by people using the flow label for local significance, using extension headers that are only valid locally, even using address bits for special purposes inside a domain. And if you read the basic documents of the DetNet working group, you will discover that deterministic networking is specifically designed for limited domains. So people are producing limited domain technologies, and there are all sorts of different limited domains in the internet. Now, the problem we have in Anima, for example, is we didn't actually define what a domain is. We sort of assume that we know by magic what a domain is and who's in the domain and who's not in the domain, and it's all supposed to be settled during the bootstrap, except that we don't have a general guidelines as to what the domain boundary is or who is allowed in and who isn't allowed in. So that's a technology gap in Anima, but it's a technology gap all over the internet as far as I can see. So the challenge we have in this area is the internet doctrine has always been internet standards are universal in scope and applicability. But in a limited domain, you need limits to the applicability of the protocol. You know, it's commonly written in various documents that this particular thing, whatever it is, must not appear outside the domain boundary, but you don't know what the domain boundary is. You hope that there's some firewall somewhere that knows it's the domain boundary and knows to stop this particular thing escaping. Also, if you have a limited domain requirement for your protocol, you might think that allows you to simplify the protocol because you don't need to worry about going across the internet. That's not actually true. It means the protocol needs to be more complicated precisely because it has to be confined to a certain domain. And its security design is certainly going to be complicated because by definition, if it's a limited domain protocol, it must not escape from the domain, and that means there must be a security design to prevent that happening. We also know from about 50 years experience that a protocol which is intended for a particular scenario will be used in other scenarios. It will escape from where it was designed to be used, and it will appear elsewhere in the internet. So the challenge we have is to reconcile those aspects, and either this is solved in a more general way, or each limited domain technology, including Anima, will have to solve it themselves. Now, it could rush off and design a solution, right? We can probably build a solution based on this question of the little authorization policeman that Turles showed us earlier for Anima. I'm a little bit reluctant to design a solution that only works for Anima. You know, maybe we could be clever enough, as apparently we've been with Brusky, to design something that other people will want to use, even though it was designed for Anima. Maybe it should be an IETF-wide discussion. I don't quite know. But I think there's some work to be done, which is to figure out the common aspects of these limited domains, make the case that some protocols should be standardized to work only inside a limited domain, and make the case that we need some sort of mechanism for defining the boundary, defining which nodes are members of the domain, which nodes are edge members of the domain, and that would have some protocol and in particular security protocol implications. I don't know quite where to go. The draft deliberately leaves these questions open as future work. I would like to know if there's interest in this working group in tackling the problem either specifically for Anima or trying to develop something a bit more general in scope that could be used more widely. Obviously, that's a discussion that we have after we have a new charter, but you know, I wanted to raise it here. The next slide, please.
Oh yeah.
We're there.
Yeah, so I didn't quite get, you know, something that could be practical done as an example out of this. But, you know, from what we've been doing so far, I think we've already seen different type of limited things happening to us, right? So in Anima specifically, I think the constraint networks, right? The whole IoT stuff, right? Where I think there is some evolving taxonomy of constraints, but I don't think it's very well understood or documented outside of this one RFC. And then I think for a lot of other things in the IETF RFCs, we've seen this binary division between, okay, it's applicable to the internet versus for controlled network, whatever that means. It's just your get out of jail free card if you're not meeting whatever the internet requirement is. So maybe, you know, because of the IoT stuff, I think we're going to ongoingly in Anima struggling to figure out how much of what draft is applicable in that particular constraint. So I think I'll have a hard time figuring out if I can come up with generic solutions if I already see that the one constraint environment like the IoT stuff, will have us do continuously ongoing specific thoughts about them. So I think what definitely would be very helpful is, a more complete taxonomy and, also recommendations on how to deal with them. I'm not sure what the best working group is to do that, right? Because things like, oh, you write a controlled network and voila, you can kind of get out of jail free with the specific expectation you otherwise have. That's kind of something you learn between the lines now in the IETF. So it's a, interesting topic.
Yeah, we've got some feedback already from Inter area, which is quite positive, and we've got people asking to have little private discussions about it. So I think there is interest, but I'm scared of it becoming a topic that's too general to have a concrete discussion about. So that's why I would like to find out if there's serious focused interest on actually solving it.
Bing Liu again. Reading the title limited domains, there are at least two different aspects pop up in my mind. I think one aspect is regarding to human operation. We need to limit the domain for scalability or for security considerations. The other aspect is regarding to if we limited some mechanism in a certain domain, it implies we can allow heterogeneous mechanism to run in differently in each domain. So I think maybe we need to distinguish different aspects. What's the implementation of the limit domains?
Yeah, that may be part of the analysis we still have to do, yeah.
I think that I like this direction, especially that in my view will have a substantially immediate effect as well as things. It is now a norm that these domains or multi-domains do exist. This technology domain do exist for the last 50 years, but also there are some administrative domains, the domains which uniformly an operator could apply a group of policies, for example, security domain or anything like that. So suddenly you have two types of domains. They do exist, which means that the common aspects for autonomic capabilities to be looked at, it's one way, but the other way, which is more practical, is to look at the multi-domain issues because they do exist, irrespective of what I'm saying or anybody else. And at the end of the day, end-to-end solutions are needed. And multi-domain, for example, coordination or orchestration is now the norm in terms of research and development. And this could be the source for additional protocols to be added in addition to the common elements which we look for. And the other aspect which I want to add is that domains are changing. So it's not a static description, which means that the edge, the core, and otherwise will change all the time. So for the way to handle this coordination of such a domain or orchestration is to look at the way in which you could change as well. So this is another dimension for this practical work, which will add value to the Anima. So I support it, and with these comments.
Okay, thanks. It's certainly been my assumption that domain boundaries and domain membership will be time varying concepts.
Roland Biske, IT. Just a clarification question. Do you consider mainly limited domains with respect to connectivity, or is it much broader in the sense that you could also use, let's say, logical associations defining domains on top of a common connectivity substrate, for example?
I would think that given the way the internet is developing, we have to assume that everything can be virtual, which means effectively the domains could interpenetrate each other due to virtualization techniques and so on. So I think the answer is, yes, anything. Yeah. I mean, that's why it's a hard problem to get hold of.
Yeah. Right. I think it's quite broad thing.
Yeah.
It's important, but since it's context related, it's quite hard maybe to come up with general recommendations.
Yeah, I know it's
Yeah.
it's hard to turn it from an abstract into a concrete problem. I completely agree.
Yeah. Okay.
Last question.
Doug Montgomery, I guess I had a similar concept. Are you trying to standardize the conceptual notion of a limited domain? Or, your list of examples of different kinds of technologies, some of these domains can be distributed. I mean, it can't be topologically based. So the definition of what is a limited domain is a function of the technology that you're trying to apply it to.
It could be. I would actually like to reduce it to a question, is this node in the domain? Is this node an edge of the domain? And if it's virtualized, that question is still valid. You see what I mean? So I think it probably can be turned into a concrete question, but we need to do a bit more analysis before we get there. And I know how I could turn it into a concrete question for the ACP. That's not hard to imagine. But if you want it to be a more general concept, then it becomes more difficult. Exactly. Yeah. Okay. Well, would be happy to have people read the document and send us comments, and we may come back to this with a more concrete proposal for the working group later, depending.
Yeah. Thanks, Brian. Dean.
This is Bino again, to give some updates on the information distribution draft. And I'll try to be as quick as possible due to we are running out of time. Okay, next, please. A brief reminder, the information distribution is a function to handle different patterns of information exchanging between autonomic nodes. And we are using GRASP as the bearing protocol. And in last IETF, we reorganized the requirement and several general different information exchange patterns, which are the instant distribution is point-to-point flood and selective flooding, and asynchronous synchronization distribution. The subpub and even queue and distributed storage. And for the last two, even queue and distributed storage, they are mostly some sophisticated handling within the node, and maybe subpub interface is already enough for them, and in terms of interface. And for the new version, next please. For the new version, in order to explain the abstract requirement, especially for the event queue and distributed storage, we include some reference scenarios that could be potentially used the information distributed mechanism. They are mainly from 3GPP 5G scenarios and 5G AA. And another part is we give some specific definition to extend GRASP. Next, please. Okay, the use case one is the network function entity. As we can see in the figure, the service consumer need to subscribe some events from the network report function. And this is quite intuitive. Next, please. This one is about the event queue. As we can see in the middle, the network exposure function. They will collect the events from multiple network functions below. And they will prioritize these events and to sort out which one should be immediately sent to the relevant application function and which one could be hold for a second. So that's a reference scenario for the event queue. Next, please. This is regarding to the distributed storage. In the 5G system, there's a logic entity called a user data repository defined. Because no network function will store the user related data, and they all need to be stored in the user data repository. And it is not acceptable for a user to statically configure the URL of the repository. It needs a function to dynamically discover and to send the message need to be stored. So that's exactly what the distributed storage done in the information distribution. Next, please. These are some multiple requirements from the vehicle to everything scenario. For example, the firmware update. It is also not acceptable that all the vehicles they connect to a single server or in the cloud to get the newest firmware. So this firmware need to be distributed storage in different edges. And we can also, it also needs some subscription when they are the newest firmware available. And the real-time HD maps is the similar logic. For example, when a car drives into a specific field, it can get the part of the HD map of the exact the place at the local edge without download it from a single point. Okay, next please. Okay, the following are some specific extensions to GRASP. The first one is a new message called unsolicited synchronization, because current GRASP only do synchronization when there's a request message, but sometimes it will need actively push the information. So we need to define a new message for that. Next, please. Then there's a option defined called selective flooding. This could be encapsulated in the flood message to indicate whether this message is suitable to propagate to other nodes or just dropped at the current node. And we also define a sub option called the match condition option. For example, there are two objects they need to be matched. One simple example is the object one could be the role of the current device, and object two could be the predefined role. For example, if this role is a CSG in the IP run, then it just drop the message. It's just a simple example. Next, please. Okay, for the sub-pub, we also propose to achieve it through an option rather than proposing new messages in order to maintain the basic grasp as much as possible. Okay, next, please. Yes, this is the unsubscription option. Next, please. This is a pub option. Okay. Yes, that's the update.
Comments? Questions? Brian?
Brian Carpenter. I just wanted to say that I had a quick look at the proposed GRASP extensions with respect to my prototype GRASP implementation and thought I couldn't really see any fundamental difficulty. Obviously, the devil is in the details. I haven't had time to actually write any Python code, but I didn't see anything fundamentally wrong. The only observation I made is the the push, the unsolicited synchronize, only works if the ASA at the other end is implemented to listen for the push, because the way the internet works, you have to be listening to receive something. So it's an extra feature in the ASA that the other end, that it should be listening for potential push.
Thanks.
Todd Spraggins with Oracle. So the extensions look useful, but I guess going to your use case for the SBA architecture, so are you suggesting that CT4 consider this as a replacement for what they've already specified for SBA?
The scenarios in this new draft not necessarily means we will go to 3GPP to let them use this. The bottom line is to give some real example of what kind of scenario might use the advanced features other than the basic grasp. But personally, the co-authors, we hope the 3GPP can consider existing tools rather than they specifying the other dedicated protocols.
They haven't specified new dedicated protocols, so they're using HTTP2 with JSON on those interfaces.
Okay, thanks.
Two questions. The first one is, I understand you want to address more the kind of mechanism and way to exchange different information. Do you also consider how to specify the information you want to convey and the meaning of those information? I mean, more going into the semantic of what you convey. Or is it completely not considered on purpose or not?
For this draft, it is out of scope for the semantic part. But still, I think you also have a draft of knowledge exchange, and maybe it's more proper to discuss the semantic in a knowledge exchange.
Okay.
And also I'd suggest we can, maybe some part of the knowledge exchange could be merged to a distributing
we
distribution.
can discuss this. Okay,
Yes.
thank you. Second point is, I mean, there are some other works in IETF around, I would say, telemetry and new monitoring protocols or aspect of collecting information, exchanging information. Do you see any relationship between what is here a bit more specific for Anima and linking it to other aspects like telemetry framework or monitoring protocols?
As far as I understand, the telemetry mostly regarding to centralized, whether whatever is controller or NOC, there's a centralized server to pull some information, the monitor information from the devices, and it is a netconf and YAML model specific. So I think the telemetry, they have concrete scope, concrete mechanism. But for the distribution, I think it's more about the devices, they interact with each other without centralized management.
Okay, thank you.
Okay, thank you, Bing. Brian? We still have two talks, so could you do it in 10 minutes?
Yes.
Okay, this should be very quick. These are just updates on two drafts related to GRASP. Next, please. The ASA guidelines, which Laurent already mentioned. We did a small update, added a section on the relationship between an ASA and a non-autonomic component. It basically says a reminder that it's the ASA's job to do something, and that do something is probably controlling non-autonomic elements of the system, either local or even remote devices, which is a sort of partial answer to one of Alex's questions, I think. because then it might be using perfectly conventional operational tools, SNMP or whatever it uses to execute its control of the non-autonomic components. Apart from that, we are really waiting for some more contributions. Probably some of Laurent's material needs to be boiled down to one paragraph to go into the ASA guidelines on the assumption that his documents will become working group documents anyway, once we've got recharted. And we're waiting for more feedback. So we're ready to put the question of working group adoption for this draft, but I think we'll wait till the recharter before we specifically ask you to do that.
Right.
Next, please. The bulk transfer over GRASP draft. There were a few minor TBD items which have been filled in. I think there's nothing controversial in the text. I think we already mentioned it in the draft, but since firmware update is now an interesting topic in the IETF, we'd just like to point out that one of the things you could do in an autonomic network is trickle firmware updates through using a GRASP-based mechanism. I wouldn't use it for high performance requirements. If you want to do your software updates very, very quickly, this wouldn't be the way. But if you're just trickling them through in the background, which seems to be the favorite method from many vendors, then GRASP would be a fine tool. And again, we're waiting for feedback, and we will put the adoption question at some point. So that's really all I had to say.
Remind me a little bit. This is not a standard approach. Yes. It's an informational document, right?
At the moment, it's informational. We could change it to standards track, but I'm not sure that's even useful, except if we need to specify a precise GRASP objective, we need to have we need that to be that name to be registered by IANA.
Yeah,
and
that could be done without this.
That can be done with an informational draft. Yeah.
Yeah. Okay. Thanks, Brian. Okay. Next, and the last. Okay. Wait. A new contribution.
Okay, my name is Taesang Choi from Etri. This is our initial draft, zero draft, trust networking, and the procedure for autonomic networking. Before I move on to this topic, actually this is not, although this is a new introduction to this working group, but we have been working on this topic for about 3 years in ITUT study group 13, and we produced 2 recommendation standards regarding on this, and one is on overview of trust networking, and the other is on the architecture, mechanism, and procedures. So basically, this initial draft is based on those 2 background work. Just for your information. Yeah, next slide, please. So this is motivation. I have introduced the current security model and its some limitations here in this slide. As you can see, the security model of the current internet is based on the assumption that all traffic coming from the internet is suspicious. And the lack of inherent security in IP protocol has led various attacks, as you know. And in the context of untrusty internet, each host should protect itself from potential risks of a hostile internet. And this protection usually takes place, as you can see in the diagram here, at the final destination. And this model operates basically in a reactive manner, which means that after receiving all arriving packets, threatening packets can be detected and and removed. And the detection of threatening packets are based on predefined rules extracted from the previous attacks. And the reactive operations of security model result in endless malicious cycle of attacks and defenses, etc. So rules has to be upgraded for every newly discovered attacks, and more complicated rules are required as more sophisticated attacks emerge. So I think most of us are understand the current security model. Could you move on to the next slide? Yeah. So here in this slide, I have the comparison between the current security model and the trust model that I'm proposing here. Those two are pretty much opposite in its characteristics. The trust model is based on the confidence that entities in a trust networking domain, which I introduced, is another limited domain, as Brian said, never do harm. And while the security model is based on the suspicion that adversaries attack anytime. And the relationship in trust model is binary in the sense that an entity trusts another specific entity, but the relationship in the security model is unary, because the entity itself must protect regardless of other entities. And with respect of rules, trust model keeps trusted IDs as whitelist, but the security model keeps threatening entities as blacklist. And thus behavior of entities in the trust model is proactive, while the security model acts in reactive manner, as I said. And that leads policy of trust model is to prevent risk by communicating only with trusted entities. But policy of security model monitors all the communications to detect and remove threatening actions. And trust model provides a mechanism for accepting entities and the domains after verifying their trust based on trust index. And while the security model provides a mechanism for watching the traffic and blocking the threatening traffics. So as a result, the network space of trust model starts with a restricted space and incrementally grows as new entities or domains are accepted, while the network space of security model starts as an unrestricted and open space, but the space may be diminished by the excluding behaving entities. So could you, next slide, please. So based on these two comparisons and limited limitations of the current security model, we try to propose a trust networking domain. The objective is to provide a trustworthy communication network infrastructure, especially for in this working group context for the autonomic computing. And the autonomic domain with respect to trust. So current autonomic domain doesn't have such characteristics, but it has a limited one. But in this proposal, we try to propose the autonomic domain with respect to trust. So it's a collection of autonomic nodes which trust each other, and host and communicating elements as autonomic nodes. And so we may need to expand the bootstrapping process with trust aspects, and then need to define trust manager as registrar, and also another component called domain gateway for the communicating with the beyond a particular trust domain, networking domain. And also we need to consider the backward compatibility with existing legacy network. Next slide, please. We define in the draft, we define what is trust networking domain. And also we define 3 different aspects, which is how we can protect this trust networking domain, and how we can expand trust networking domain for the scalability purpose. And also we define how to communicate with the external domain, with external trust networking domain. You can see those 3 cases in the diagram. Next slide, please. So we define this trust networking domain as an application of Anima. It's kind of the the subfunctions defined in the trust network domain are a set of ASAs. So it has trust gateway function. It's kind of ASA, as you can see that. And since all nodes within the trust networking domain maintain a certain trust level set by the domain, communications within the domain can be done without any further security concern. And communications with external node, however, requires additional verification phase before the communications actually begin. So the verification is performed at the border of the domain, where the external nodes are checked if their trust level are sufficiently high for the domain. Next, please. Yeah. Next slide, please. For the configuration, so we have trust management plane, which takes care of the configuration and provisioning of the identities of the nodes within the domain, and also it performs the trust evaluation, whether that nodes is can be accepted as a trustable entity in the domain. So due to the time limitation, I think yeah, I can go into the next slide. So here for the mentioned process, the first step is identification. So in a trust networking domain, each autonomic node should be identified. As an example, in our proposal, we are defining an ID called self-certifying ID, which is a set of private and public key pair, and also the hash of the public key is defined as self-certified ID of the node. This is an example. And this ID can be used in validated check of a claimed key against the actual public key of the entity. And also, not only this self-certified ID of the identification method, we also define a trust relationship between the nodes. So both identification and trust relations, it has to be satisfied in order for the autonomic nodes to be trustable in the domain. Next slide, please. So and then next steps is to discover and the signal between the nodes within the trust networking domain. So the trust management information database is used for discovery of autonomic nodes, and also from the signaling point of view, I think since this group has already defined the aggressive protocol for the signaling purpose, so we can utilize the existing mechanism for communicating between the nodes. If there is any specific extensions needed, I think we need to consider, but I think that's for further study, I guess. Okay, next slide, please. So another important aspect is the trust evaluation for each node, whether that node is trustable within the trust domain. So the evaluation network is the way of calculating trustful networking services. It requires data collection from various sources, the physical and the local data sources. As you can see here, previously manually configured by the policy management, etc. So based on this information, it performs the trust evaluation and then make a decision that the node or entities within this domain is trustable. And we are still working on this trust evaluation mechanism under the scope of trust index, and then I think we still need to work on this aspect. Okay, next slide, please. So in the draft, we defined as a use case, we defined two procedures. One is for node registration as an autonomic node to register as a trustable entity within the domain. And you can see the node, one node in the diagram here interacts with a domain gateway. The domain gateway assigns the private IP address to the node, and then also the domain gateway is assigned as a default gateway for the IP network. And trust information management ASA, there are 3 ASAs defined for this purpose. One is a trust information management ASA, and the other is domain member management ASA, and third one is the ID location management ASA. So through these interactions, autonomy node can be registered as a trustable entity in the trust networking domain. Okay, next slide, please. So this procedure is for communication between 2 different trust networking domains. So, for example, here in the host 2 wants to communicate with host 1, which is in different trust networking domain. To do that, host 2 first contacts with a trust domain, its own domain gateways, and then through the ID mapping from the generic ID, the self-certified ID to specific ID to specific to each trust networking domain. Those can be done by these the ASAs defined. So currently we defined these 2 procedures as use cases, and we are going to work on the further use cases in the future. So this is a brief introduction on the trust networking for autonomy networking. So kind of extension of the trust aspect to the autonomic networking capabilities. So as the next step, since this is our initial work, we would like to welcome your comments and feedbacks, and then try to update document prepared in another version if working group feels interest on this work. Okay, thank you.
Yeah, Xing, at the very beginning, I think what you described for the trust and security is what I think what we would like to have. But when you go through your design, I actually realize what your design target is what we already achieved in the Anima. We already have the trust system, the boundary, and the way to discovery and to communication to each other within the autonomical network domain. The only thing missing from the current Anima, to what you described here is only the the communication policy in data plan to stop the nodes to talk to the other nodes out of the network boundary. So I'm get lost. What do you want to standards here? What the extra goal you want to achieve here?
Okay. The current Anima, this working group, as far as I understand, regarding on the security capabilities, you define the risk and the during the bootstrapping and enrollment process, you're applying the security mechanisms to do that. I think that's basically explicit security mechanism we have defined in this working group, right? And then beyond that, the communication aspect between once it is involved and you consider that as a secure enough, then you do not apply any particular security mechanism for the communication between the entities.
I think you mentioned that you had been doing something like a prototype or demonstration or so. I think if we had, a little bit more idea about the practical implementation or, thing of your concept, then I think it would be easier to map it to the Anima case.
Yeah. Actually, we have a proof
Do you
of
have
concept
any slide, or is
implementation.
there? Can you talk about that quickly, briefly?
Actually, we have implementation, but what in our proof of concept, what we implemented is the main concept here is the domain gateway capabilities.
So what does it do?
The domain gateways, it consists of three things: the identification, and then repository management.
Sorry, what?
Those three functions. Could you? Yeah. Trust information management and domain member management, and then ID location management. So those three capabilities has been implemented as our proof of concept, and we can provide a little more detailed information to the working group in the next meeting.
So right, the identification, I guess I have an idea what that means, but the other pieces I have no clear. Yeah, I read the draft, but it's still kind of, for me, difficult to translate. So I was thinking, okay, so this is some form of a firewall where the policies of the firewall are determined on an authorization profile of the identity of the neighbor or something, but I'm just guessing, right? So that's kind of, it's always hard to overcome somebody else's terminology that you're unfamiliar with, right? You heard that I've been thinking about different terms, and if they mean the same thing, that obviously helps a lot to more practically envision what you're doing.
Okay, that's why I described two procedures. One is on the node identification registration, and second procedure here is the communication between two nodes within two different trust networking domains. And within this procedure, you can see those ASA's capability. Functions. What those functions are.
But would it be fair to say that communication function is something like a firewall, where basically you're
domain gateway
filtering, allowing only certain type of traffic, or?
Yeah, domain gateway is basically, you can consider it similar to firewall, which sits in the border of domain gateways. So once it is identified as a trustable entity within trust domain, communication between those entities can be done without particular security measures, because we consider that as trustable enough. But between the trust networking domains,
Brian Carpenter. Now I've got two comments. One is I found your slides easier to understand than the draft. The draft left me very unclear what the relationship to the ACP is and what the relationship to Bruschi is. You have some references in your list of references, but you don't use them in the text, and it really would be much easier to understand if you were very specific when you say in the autonomic networking context, this function is done by Bruschi, this function is done by the ACP, and so on. That was very unclear to me. The other thing, which comes back exactly to what Turles was asking, is I don't understand how your domain gateway can actually authenticate and check addresses. How does it protect itself against spoofed IP addresses? And how does it do this at line speed? Because I couldn't understand how that could work without going through a cryptographic processing for every packet, and I don't think you want to do that. You don't need to answer now, but in the next version of the draft, it would be very helpful if this was explained much better.
Is Choi from KAIST in Korea. We have several type of the use case. We have some application layer use case, also in the transport layer use case. For the application layer use case, we currently developed some discriminate on the top of the IPTV service. We classify a lot of different type of the media, and we have a separate up to what kind of the trust domain to build up on the top of them. Another one is a sharing economy. Sharing the car looks like Uber. We have a discriminate it's a customer. Such a customer is trustful enough. Some of the customer is not so trustful enough. And that kind of scenario we try to apply to the trust model on the top of them. That is kind of the scenario. We have a lot of the scenario. We already implemented in the real application. But this issue is not the network issue. In the application level issue, we apply to the trust concept.
I think the main concern seems to be that the main differentiator or what is the gaps that this draft try to propose on top of the existing working group security measures. So yeah, we'll try to identify and then try to describe it in
I guess I need to ask a clarification question. Is your purpose here to explore a deployment use case of which you use Anima components in your network, serve your application level SaaS, or you try to define some new components new Anima component to serve your purpose? Which one is it?
Actually, it's more latter case. Yeah, we try to add on the gaps that current Anima specifications.
I mean, if that's the first one, I'm fine with it. But if that's the later one, I still don't get to the point. What do you want to standardize here?
It's one of the background we proposed the trust concept. We review each 3 years ago. We already reviewed the existing all of the tangible security technology. Security technology is enough. Anyhow, actual result came from the human who believe the human behavior and any kind of the transaction. Eventually, we have any kind of security technology is not enough. And then we directly focusing on what a human really believe or not. And then in combined with the Anima concept, we have some of the network management function, and the network equipment function, we believe that such a kind of the network equipment function is believed enough, and then we build up the trust enough. But within that environment, we try to compare to a lot of the tangible security technology. We developed a lot of the way, and then we have to compare to just a simple security trust concept enough is a right way, also more acceptable.
Okay, just as a summary, the reason why we are trying to define this trust-related capability as ASA is not instead of infrastructure capabilities. This is kind of an application extension to the existing Anima. That's why I answered to Xiang's comment.
No, thank you very much. It's just that, I think 5 minutes ago, this turned from a working group into a hostage situation because we've ran out of time. So thank you very much, everybody. Please take everything that you still want to discuss to the list. And then hopefully we'll see each other again in Bangkok. Yeah.
Shall I talk to you guys? Shall I talk to you guys?
Yeah, okay. Just